Here you have the fifth one. A ray or ray which seems to be traveling through the focus of a convex mirror, path of the reflected ray of an incident. So here you have options are option A, parallel to the principal axis, option B, along the same path in opposite direction, option C, through focus, option D, through center of curvature. Now here the given question is a ray which seems to be traveling through the focus of a convex mirror, path of the reflected ray of an incident. Firstly guys, let's understand this with the picture, okay, with the diagram. So here the correct option over here is for now is parallel to the principal axis is the correct option. So now let's see how it would be. Here you have firstly they asked what a ray which seems to be traveling through the focus of a convex mirror. So here let me draw a convex mirror somewhat like this. Okay, this is the convex mirror. Okay, now it is like somewhat like bulged inwards. So here I have got a silver coating inwards. Here you have silver coating, clear? And now let me draw a principal axis through it. Now this will be pole. What will be this? This will be focus, and here you have what? Center of curvature. Now here guys, if a ray is traveling towards the focus, okay, so something that ray starts somewhere over here. If a ray, so this is what? This is principal axis. Principal axis. Okay, this is principal axis. Oh, clear? Okay. Now here, if a ray is traveling towards the focus, if a ray is traveling towards the focus, something like this, okay? If a ray is traveling towards the focus, and then what happens? Wait a minute. Towards the focus, and what happens here is, if a ray is traveling towards the focus of a convex mirror, then it becomes parallel to the principal axis. It becomes parallel. So this ray is parallel. So here it becomes parallel to the principal axis after reflection. So after reflection, so this is the ray which is going towards the focus of the convex mirror. Then after reflection, it becomes parallel to the principal axis. Okay, so here it is becoming parallel to the principal axis after the reflection. So this is the reflected ray. This is what? This is reflected ray. Reflected ray. And this is what? Incident ray. This is incident ray. Just writing like that, but okay, this will be the incident ray guys. Okay, this will be the incident ray, this is reflected ray. So here reflected ray is getting parallel to the principal axis. Clear? Hey guys, now here you have the sixth question. Size of the image formed by a convex mirror is always. Now here you have the option A, enlarged, option B, diminished, option C, equal to the size of the object, option D, depends on the position of the object. Depends on the position of the object. Now coming back to here, where the size of image formed by a convex mirror, where convex mirror always forms a diminished image guys, okay? They form a diminished images. So therefore here, among the given options, I can say where B will be the correct option, where diminished. Now coming back to here, where convex mirror, the size of image formed by convex. So here, where convex mirror is mostly used in like we use mostly convex mirror in when convex mirror is used as rear view mirrors in vehicles. Okay. So what happens here is this rear view mirror, which is there, it tries to where you will be having you can see the more amount of view field. Okay. So where you can see the larger amount of view field is being seen from the concave mirror in the vehicle. So the drivers who are there, they can see the vehicles which are coming from the back. Okay, so they can see larger amount of view in the rear view mirror. Clear? Now next you have a few other examples for this convex mirror will be convex mirror. You have telescopes, right? Telescopes, magnifying lenses or etc. So this all will be the example for this convex mirror. You have a seventh one. An object is placed at a certain distance of the principal axis of a concave mirror. The image is formed at a distance of 30 centimeters from the mirror. Find the object distance if radius of curvature r equals to centimeters. R equals to 15 centimeters. Now here, let's understand the question, guys, firstly, okay? Okay. Now here, a concave mirror, we have a concave mirror where an object is placed at a certain distance on the principal axis of a concave mirror. Now the image is formed. So image distance, we know when image distance is denoted by V, right? V. Okay. So the image distance is denoted by V and object distance is denoted by what? U. So the image distance is denoted by V and object distance V is denoted by U. So therefore the image is formed at a distance of 30 centimeters. Where V equals to 30 centimeters we can say. And from the mirror, find the object distance. So here the question is, they are asking to find the object distance. What is the object distance? They have given V value and they have given R value, radius of curvature value, where R equals 15 centimeters, and they are asking what? They are asking to find this object distance. Means U value. Firstly, the given options are here. Option A 15 centimeters, option B 10 centimeters, option C 30 centimeters, and option D 7.5 centimeters. 7.5 centimeters. Firstly, let's wrap the options. Okay, we will again come back to the options. Firstly, let's solve the given question first. Okay, let's solve the given question, guys. So the solution, and what's the given question over here? So this is the question we got. We already got this question right now. I'm not going to elaborate it. So here the image is formed at distance of, image distance, where image means V equals to 30 centimeters. V equals to what? 30 centimeters. And what else? From the mirror. Now here where R, they have given R, where radius of curvature, where R equals to 15 centimeters. And we must find what? U value. We must find U value where U equals to, what is the U value? What is the U value? What will be the U value? Okay. Now here let's find the U value firstly. By using mirror formula, let's find, guys. Okay. We know mirror formula, where mirror formula means where 1 by F equals to 1 by V plus 1 by U, right? So this is the mirror formula, right? This is it. So this is the mirror formula, right? We know. Now here where 1 by F, first we know the F value, V value where V equals 30, but F value, let's find the F value first. Okay, by finding F value, we can by using and by substituting we can find the U value easily. Okay. Now first let's find the F value, where F means here there will be a formula for F, focus or focal length. Now here F equals to focus equals to radius by 2, means R by 2. Okay. F equals to R by 2. So where R means radius, right, here where R is given what? 15 by 2. Right? R means 15 by 2. So therefore here I got what? 15 by 2. F equals to R by 2 equals, which is equals to 15 by 2. Now here V equals 30 centimeters, R equals 15 centimeters. Now here we got what? F value I got, right? F equals 15 by 2. Let it be like F equals to 15 by 2 centimeters as it is. Now let's write down over here, right? So let's write down the data over here like given where V equals to 30 centimeters and what else? F equals to 15 by 2 centimeters. Let me write. Now what you do is first here. Now let's solve by using the mirror formula. We know mirror formula, right? Where 1 by F equals to 1 by F equals to 1 by V plus 1 by U. So this is the mirror formula, guys. This is not 4, this is U. Okay, sorry. It might look something like that, but yeah, 4. Sorry, V, U. Okay, this is U, 1 by U. So the mirror formula is 1 by F equals to 1 by V plus 1 by U. Now here we got F value. Let's just substitute it over here. We got the value. So just write down here where 1 by F. F value is what over here? 15 by 2. Let it be 15 by 2 equals to 1 by V. V means 30, right? Where V value is 30. 30 plus 1 by U. Clear till here? Very good. Now what you do is where 1 by 15 by 2. If I reciprocate, so here if I write further step, it becomes what? 2 by 15. Okay, this becomes reciprocal and this becomes what? 2 by 15, somewhat like this. So this is equals to 1 by 30 as it is. 1 by 30 plus 1 by U. Clear? Now what you do is, we 1 by u. Now what you do is just transpose this 1 by 30 to the other side. Let me write down the further steps over here. So now here, when I transpose this 1 by 30 to the other side, this becomes what? If I transpose 1 by 30 to the other side, this becomes what? 2 by 15 minus 1 by 30 equals to 1 by u. Okay? 2 by 15 minus 1 by 13 equals to 1 by u. But this becomes, by taking LCM method, by taking LCM, we can write like 30, where 30, where LCM into numerator by denominator. Sorry. So LCM into numerator by denominator, this becomes 4 minus 1 equals to 1 by u. Okay, this is 4. So now here 4 minus 1 by 30 equals 1 by u. Now 4 minus 1 we gives 3 by 30. 3 by 30 equals to 1 by u. Now where 3 times 1, 3 ones 3. Here look after here, where 3 table. Just look after the 3 table. 3 ones are 3, 3 tens are 30. This becomes 1 by 10. 1 by 10 equals to 1 by u. Now by cross multiplication. This becomes what? Where u into 1, u 1, 10, 10. So this becomes u equals to 10 centimeters. U equals to 10 centimeters. Clear? Done? So this is what we got. Therefore, I got what? U equals 10 centimeters. So among the given option A, they have given somewhat like 15 centimeters maybe. Option A 15 centimeters, option B 10 centimeters. So there, here you can say option B is the correct option. Okay, where option B equals to, they have given what? Option B as 10 centimeters, where 10 centimeters will be the correct one, guys. Okay, so option A 15, option B 10, option C might be 30, option D might be 7.5, but among the options, where option B 10 centimeters is the correct option according to the given question. Clear? Done? Thank you. Okay, here you have the 8th one. All the distances related to spherical mirrors will be measured from. So here you have the options, where option A, object to image, option B, focus of the mirror, option C, pole of the mirror, and option D is image to object. Now here, starting with it, all the distances related to spherical mirrors will be measured from at what point? So at what point the distances are measured in the spherical mirrors. So mostly guys here, first let's construct a ray diagram, okay? So by constructing a ray diagram, let's understand very briefly. So here you have, I would like to make a, let's make a concave mirror. So this is the concave mirror by silver coating over here. Here I got a silver coating. Okay, so here you have the concave mirror. Now let this be let me draw this principal axis. This will be pole, guys. Okay, right? Here will be pole. This will be pole, and what else? Pole, focus, center of curvature. So focus, and what else? Center of curvature. Now we know where pole. Firstly, the option will be C, guys. Where pole of the mirror. So where the distances, where all the distances are measured from. Where all the distances in spherical mirrors are measured from the pole of the mirror. All the distance in the spherical mirrors are measured from at what point? It is measured from pole of the mirror. Actually here you have pole of the mirror, so all the distances are measured from at this point. As here, where from pole to the focus, it will be focal length. We can consider this as focal length, right? Focal length. So we can consider this as focal length as well, where pole to the center of curvature. Pole to the center of curvature, we will be measuring this, where this is, where here this distance, okay, where pole to center of curvature, this distance is said like, where we say this distance as what? Radius of curvature. Okay, this is called as radius of curvature, where pole to center of curvature will be radius of curvature, and where pole to focal length will be, pole to focus will be focal length. Clear? Now as well, we know where image distance, right? Image distance is denoted by V, okay, and object distance is measured from pole. So therefore I can say C where the distances, okay, so the distances related to the spherical mirrors are always measured from the pole of the mirror. Clear? Welcome. Here you have the ninth one. The minimum distance of real image to a real object, or the minimum distance from a real object to a real image in a concave mirror is. So here you have the following option, guys. So the option A is 2f means 2 into focal length. Option B focal length. Option C 0. Option D focal length by 2. F by 2. Clear? Now, firstly, they're asking what the question talks about, like the minimum distance from real object to a real image in a concave mirror. So firstly, let's do one thing, right? Place an object. Let us place an object on the center of curvature. Okay. Now what you do is place an object on the center of curvature. So here I have drawn a diagram where this is the concave mirror, principal axis. Okay. You have pole over here, pole, focus, and center of curvature. Now here, this will be the center of curvature. Now we have placed an object over here on the center of curvature. Now the first ray which is there, so the first ray passes to the parallel to the principal axis, and it comes back, like it comes back after reflection. It comes in this direction from the focus, and the second ray which is there, it passes through the focus. The second ray which is there, it passes through the focus. This will be the direction, guys. Okay, it passes through the focus, and after reflection it comes back. Okay, it bounces and it comes back like this. Now here, this will be the object. Let's name object as AB. Okay, AB will be the object, and now the image formation. So here the image is forming. Where the image is forming? Here the image is forming at this particular point where the two lines are converging, where two lines are meeting. So that point where the image is being formed. So the image is forming somewhere here. So here I can draw a line like this. Okay. So this is the place where the image is being formed. So here by this, let's name it as B dash and A dash. Okay, where B dash and A dash will be the image formation and AB will be the object. Okay, real object plus and real image plus. Now here we can say where the object and image are forming, they both are forming at a particular place. Okay, where object is over here and the image is forming over here, where there is no distance between the real object and real image. So therefore the distance between the real object and real image in a concave mirror is 0. Okay, is 0. 0 means option C, where option C will be the correct answer for the given question. So here when we place an object at the center of curvature, so when we try to pass two rays through it, so here we can see the image is forming somewhere over here. So therefore where object is over here and image is forming just below the object, so here there is no place. Okay, there is no distance, actually distance between real object and real image. Clear? So therefore option C is the correct option.